Welcome back all the fans and followers of space fiction. I just wanted to send you my selfie from Saturn, but I realized that you are still missing the third important part of the space infrastructure. Infrastructure is a very broad concept. In general, it is a group of devices or objects that allow people, resources or informations to be transported from one place to another. And in this video, we will take a closer look at the third and perhaps the most important part of space infrastructure, space communication. If I ask you about space communication, then surely you will all confirm to me that this is nothing new and that you are already using space communication. So let me prove how wrong you are. The space communication that is taking place today is the communication between Earth and several space probes that flew to the Moon, to Mars, or that got lost somewhere in space. This communication is provided by several powerful Earth stations. For example, for US space missions, it is NASA's Deep Space Network, which uses 3 stations to receive and send signals. The first one is the Goldstone Observatory in California, the second near Madrid in Spain, and the third in Canberra, Australia. Their distribution on 3 different continents is intentional to ensure signal reception from the probes throughout the whole day. The Earth rotates, and thus no observatory on Earth can communicate with the probes for 24/7. The first problem is therefore the rotation of the Earth, and the second the capacity of this system. Each antenna on Earth can communicate with only one probe at the time, and the data flow is limited by a large distance from the Earth. Therefore, they cannot be used for civilian use and a large number of users. But what will communication in space look like in the future? There will be a large number of bases and even more people on the Moon and on Mars. And there will almost no longer be a scientific mission. There will be some scientific missions, but they will represent only a small percentage of all crews. The majority of the population will be workers and tourists. Both will want to not only communicate regularly with their families, watch television, but also use the internet and its services every day throughout the year. So can we do it? With the proper infrastructure, for sure. With bases on the Moon, it's a little easier, because if you are not on the far side of the Moon, you have Earth almost in the same place in the sky all the year round. Audio and video transmission is not a technical problem. The response only takes 2 seconds, which is still a time that doesn't matter in a normal conversation. By the way, the first phone call to the Moon took place in 1969, when President Nixon congratulated Armstrong and Aldrin on the first landing on the Moon. It would be similar with signal transmission for the internet. Although the pages would always load 2 seconds later than on Earth, you can still work with that. However, what needs to be ensured are telecommunications satellites to transmit this large amount of data and calls. Since it is not possible to use Moon's stationary orbit because of the slow rotation of the Moon, telecommunication satellites would need to be placed close to the L1 Lagrange point in the Earth-Moon system. This point represents the space around which cosmic bodies can rotate relatively stable to the Earth and the Moon. In addition, such satellite would be only 1.5 times farther from the Moon's surface than conventional geostationary satellites from Earth. Thus, their range would still be fine for ordinary users without the use of large and expensive antennas. However, communicating with Mars is a much bigger problem. When Mars is closest to Earth, the answer to the question will reach you in 8.5 minutes, and when it is farthest from Earth, it will take up to 42 minutes. Such time does not allow you to do discussions or work with the internet. In addition, about once every 2 years, Mars hides itself behind the Sun, and then it is not possible to communicate with the planet at all. So how can we solve this problem? Such an infrastructure will need to have several levels. The first level will be a network of telecommunication satellites in a stationary orbit around Mars, as it is on Earth. Everyone on Mars' surface will be able to communicate with these satellites just like we do today. The advantage of Mars is that its stationary orbit is not as far as on Earth, it is about half closer. By the way, the geostationary orbit around Mars is called aerostationary orbit and is located between the orbits of its two moons, Phobos and Deimos. And because of that, as you will be standing on the surface of Mars, you will definitely notice that each moon travels across the sky in the opposite direction. The second level will be satellites located at the Earth's and Mars' Lagrange points in the system with the Sun. At Earth, this communication device will be located at point L2 of the Sun-Earth system. At Mars, it will be located at point L1 of the Sun-Mars system. Orbiting satellites will communicate with these devices, and it will be the main node for sending data further into interplanetary space. The last third level will be a system of several satellites with powerful antennas orbiting the Sun in the same orbit at regular intervals, halfway between Earth and Mars. Their number depends on the quality and strength of the signal they will transmit. These satellites will receive and send data to each other in both directions. The nearest satellites to Earth and Mars will communicate with the level 2 communication satellites for each planet. In this way, you can communicate with Mars even if Mars is hidden behind the Sun or if one of the satellites fails. Therefore, you will no longer have to aim any large and expensive antenna from Earth directly to Mars. People will have to communicate through comprehensive messages, whether text, audio or even video. In practice, it will look like I will tell to the camera how I do and what's new, save the video and send it to Earth. And I will get an answer in the same way. It will be a bigger problem with the internet, because it is not possible to work with the terrestrial internet at such a distance. Mars will have to have its own internet, and the transfer of information between Earth and Mars could have to be done automatically in regular batches. And they will probably only send data dedicated for Mars and Earth. So don't expect when I upload a video to YouTube on Earth, my friends on Mars will be able to watch it tomorrow. Such huge servers won't be probably duplicated. Now you know what needs to be done, so I hope you can go on vacation to Mars soon. So go to work. When I return from a trip around Neptune, have your new space infrastructure ready. Thank you for watching, and the next time I fly by the Earth, I will send you another video from the world of space fiction.